Okay guys, we are doing lesson 4-6 today, which is the last lesson of the unit. So before we start, we're going to add last two definitions to our vocabulary page. So our two definitions are a system of linear inequalities. And a system of linear inequalities are made up of two or more linear inequalities. And an example could be y less than 2x plus 1 and y plus 2x greater than negative 2. And as always, we can put those together using the curly brackets. The second definition is a solution of a system of linear inequalities, and that is an ordered pair that makes all the inequalities in the system true. So for that system that we used in the previous example, 0, 0 could be a solution because when I plug it into the first inequality, I get 0 less than 1, which is true. And when I plug it into the second inequality, I get 0 greater than negative 2, which is also true. So 0, 0 is a solution to that system. So let's turn to page 52 of our notebooks. And get that page set up. So we're doing 4-6 systems of linear inequalities, today's date. And this page is going to be mostly examples. There is one small set of notes that I want you to write down, and that is when we are graphing a system of linear inequalities, we're actually going to graph exactly the same as we just did on Friday, but this time there's going to be two sets of shading. And the solution to the system of linear inequalities is where the shadings are going to overlap. So I would suggest using different colors or a highlighter or something so that we can indicate where those overlap. And then here's our first example. We are going to graph the system y less than 2x minus 3 and 2x plus y greater than 2. And we're going to graph that. So let's graph this first inequality, y less than 2x minus 3. This is already in slope-intercept form, so we can go straight to graphing. I'm going to graph it using green. If you have different colors, you can graph using different colors, or you can use your pencil, and then I'll show you how to indicate where your answer is. So for this one, my y-intercept is negative 3, so I'm going to go down 3. And my slope is positive 2. So I'm going to go up 2 over right 1. And then I always like to do a third point. So from my intercept, I'm going to go down 2, left 1. And then this inequality is less than. There is no equal to, so it's a dotted line or a dashed line. And the inequality is less than. So that means I'm going to shade everything below that dashed line. So far we have half of our system graphed. For the second inequality, 2x plus y greater than 2, I need to put it into slope-intercept form, so I'm going to subtract 2x from both sides. And that is going to give me y greater than negative 2x plus 2. So that's the inequality that I'm going to graph. So my y-intercept is +2. And my slope is -2/1. So I'm going to go down 2, right 1. And then I always like to go in the opposite direction. So I'm going to go up 2, left 1. That's a greater than symbol. So it is also going to be a dashed line because there is no equal to. And my symbol for this one is greater than. So that means I'm going to shade everything above this line. So this whole area gets shaded. Now, all of this shaded area is not my solution. My solution, remember, is where the shadings overlap. So I'm only going to highlight as my answer where I see green and blue shading because the points have to make both statements true. So you can, if you're using pencil, just shade it extra dark in that area. You can erase the stuff that is irrelevant, or you can use a highlighter to highlight where your answer is, which is what I'm going to do. So the area where there is green and blue shading is this area above the blue line because it was greater than, but below the green line because it was less than. So my answer is actually that highlighted area. And that's graphing a system of inequalities. So you're also going to see problems where I give you the graph and I want you to come up with the system. So that's the next example. You might need to pause the video so that you have enough time to copy down the graph. So your question is, what system is represented by this graph? So when you're drawing your graph, this solid line has a y-intercept of -1 and an x-intercept of +1. And so you can draw a solid line through that. And it is shaded above that line. This dashed purple line has a y-intercept of 5, and it looks like you go down 1 and right 2 to get the next point, and then it's a dashed line and you shade below it. And this highlighted area is the solution. So for writing a system of inequalities for this graph, I'm just going to go one line at a time, and I'm going to put everything in slope-intercept form. So for this pink solid line, I'm going to use our y, and then I'm going to leave the inequality out for right now. I'll do that last, but let's write the rest of the inequality. So I know that my y-intercept is at -1, so it's going to end up being something x minus 1. And to get to my next point, I just go up 1 and then right 1. And then I go up 1, right 1 again, and that gives me another point on the line. So my slope here is just 1x, since my rise is 1 and my run is 1. The shading is above this line, so that has to be a greater than inequality. And it's a solid line, so it's a greater than or equal to inequality. And that's the equation for the pink line. Then we're going to do the exact same thing for the purple dashed line. So I know I have my y. I'm going to leave a little blank area so I can fill out the rest. My y-intercept of this one is at positive 5, so I know it's going to be something x plus 5. And from my y-intercept to get to the next point, I'm going to go down 1, so I know that that's a negative 1, and right 1, 2. So that's a slope of negative 1/2. This inequality is shaded below, so I know it's going to be a less than, and it's dashed, so there's not an equal to underneath. So my system for this graph is y greater than or equal to x minus 1 and y less than negative 1/2 x plus 5. My last problem is a word problem. So I'll give you, pause the video so you have enough time to write down the whole word problem. You are planning what to do after school. You can spend at most 6 hours playing basketball and doing homework. So I'm going to underline that at most 6 hours doing one of two activities. You want to spend less than 2 hours playing basketball. So I want to spend less than 2 hours total playing basketball. And I want to spend at least 1.5 hours on homework. So what you are going to do is you are going to write a system for all of these scenarios and graph them, and we're going to represent the answer on the graph. Before we start, we have to identify what our variables are. So our variables are the hours playing basketball and the number of hours doing homework. So I'm going to let x equal the number of hours playing basketball. And I'm going to let y equal hours on homework. So in this problem, we actually have 3 different inequalities that we're going to write. The first one is going to be how many hours total we want to do both activities combined. So I want to spend at most 6 hours playing basketball and doing homework. So if x is my number of hours playing basketball and y is my number of hours doing homework, I want both of those to combine to be at most 6 hours, which means I don't want to spend any more than 6 hours doing it. So that's going to be less than or equal to 6. Because 6 is my maximum. So let's actually graph that right now before we do the next inequality. So my x is going to be hours playing basketball. My y-axis is going to be hours doing homework. And I only need the first quadrant because I can't have negative hours. So everything is going to be in the first quadrant. I had to squish my graph so I could fit it all. But I went to the right 8 spaces and up 8 spaces. So in order to graph this, let's put it in slope-intercept form. So I'm going to subtract x. So this is going to be y less than or equal to negative x plus 6. So on my graph, that is a y-intercept of 6 and a slope of negative 1. So that's down 1, right 1, down 1, right 1. And that's a solid line. That is shaded below. So everything below that pink line is any combination of basketball and homework. So let's write an inequality for hours playing basketball. So that's just going to be x, and I want x to be less than 2 hours. So that one's pretty easy, x less than 2. It doesn't say I want to spend exactly 2 hours, it has to be less than 2. So that only goes through the x-axis at 2, so that's a vertical line, and it's going to be dashed. And all the x's that are less than 2 are everything to the left, because that's where they get smaller. So it's everything to the left of that dashed purple line. Now my last inequality has to do with the amount of hours playing homework. I want to spend at least 1.5 hours on homework. So I want y to be at least. So I want my y's to be greater than or equal to 1.5 hours, because this is the smallest amount of time I want to spend. And since it said at least, I can do 1.5 hours. So that's going to be less than or equal, greater than or equal to. So that's going to be a horizontal line through 1.5, which is right here, and that's solid. And y is greater than or equal to that, so that's going to be everything above the orange line. So I'm going to use my highlighter again, and the solution that satisfies all 3 of these linear inequalities is the area where all 3 overlap, which is below the pink line, to the left of the purple line, and above the orange line. So your answer is going to be this little section right there. So what you guys can do is start working on your homework. We will do the left-hand side of this page tomorrow when I am back, as part of a review before your second quiz.